Hello everyone, my name is Henrique and this is the second video of this series, how to build decentralized applications using Golang with Cartesi. In this second video, I'd like to invite you to dive into the architecture behind the Cartesi rollups framework, the mechanism of input, the variety of outputs that could be produced by our application here, and more. Are you ready? Let's go! So I will take the architecture section from the Cartesi docs to explain more about what we did in the last video and more details about the Cartesi rollups framework. Basically, what we have is a framework that has a on-chain side and an off-chain side. In the on-chain side, we have a bunch of contracts that can handle inputs, assets, and also contracts related with consensus models. In the off-chain side, we have the rollups node here that hosts our Cartesi machine. I will talk more about the Cartesi machine later, but for now, you just need to know that our application runs inside of the Cartesi machine, and the Cartesi machine runs an entire Linux, so that's why I can use Golang and almost all technology to develop decentralized applications. And here we have a standard backend. Build it with some web framework like Next.js, Vue.js, and whatever you want. Then let me talk more about the Cartesi machine. So the Cartesi machine is actually a machine emulator implemented on top of the RISC-V64 microarchitecture. It has a full Linux OS support. Again, that's why I can use Golang to develop applications. It has other properties like isolation and reproducibility that gives to you the guarantee that our application running inside of the Cartesi machine is running inside of a deterministic environment. We also have a very important point here, that is the Cartesi machine is self-contained. So what it means, our application can't make external requests to outside of this environment. So with this, we don't have external influence to the computation performed inside of this environment, and our application can achieve this reproducibility. Now, I would like to talk more about the data flow and the outputs that could be produced by our application. I will take this image here to explain the data flow of an advanced state, the operation that we also did in the last video. Basically, each input goes through the blockchain, and now when we have this registered, the validator node can read this and load this input into the Cartesi machine to be processed by our application. Our application in this case can produce after the computation three types of outputs. Vouchers, which is an executable output. Notices, that is very close to smart contract events, and reports. Also, we have here the application frontend that can fetch all the outputs from the JSON RPC API or the GraphQL API. Now, I'm gonna explain more about the data flow of an inspect. A inspect call, as I said before in the last video, can only produce reports as outputs. So basically what we have is the application frontend interacting with the HTTP API provided by the node, and then sending post requests to see what's going on inside of our application, only reading the application state. Let's stop it here for now. This will be the last time that we visit the Cartesi docs to see more details about the rollups framework. But for now, I want to show all of these details in practice, building a more complex application that can, for example, generate notices. And the idea here is keep it very close with a standard Golang backend. I just created this project here with the Cartesi CLI. As you can see, it has the same layout of the previous one. But the idea is try to build this specific project as a Golang standard backend. To do it, I will try to follow the Golang standards and the structure of the project provided by this project right here and widely adopted in the Golang ecosystem. To start, I will move this rollups folder to the package folder, and then move this dApp.go to CMD. I'm gonna create a new folder here, call it to do, and move this inside of this. Okay, I'm gonna start the implementation creating a router for our application. To do it, I'm gonna create this file router.go with that is part of the package rollups. So the idea of this router is allow us to deal with multiple advanced state handlers, because as you can see, we are building a to-do list project, and for example, I can create, delete, and even update my to-do list. I have 3 types of handle advance that could be performed within this application. So I will start defining the advance state function type. That is a function that receives a payload, which is a byte payload, and also a metadata that is part of this same package, so we don't need to import this. And then it throws an error if there's something wrong. Then what we have to do is create the type router as a struct that has advanced handlers, which is a map for a string and advanced state func, exactly. Then let me create a new router that returns a router, and yes, that's exactly what you want. Then let me create a function that is a method for the router, and it is called handle advance, and receives as parameters a string and also a handler, which is an advanced state function, and define exactly like this. Then I'm gonna create another function right here, part of the router. I'm gonna call this advance. It will receive a payload of type bytes and the metadata byte, and throws an error if something wrong. So the idea here is receive a payload. Let me correct this. The idea here is receive a payload that will be always a JSON payload, and always will have the key called path. Then let me improve our logs here. Right, we need to transform this byte in a string if I want to understand what's going on. And then, no, okay, let me remove this metadata here. It's not like important for now. Yes, we have this log here to help us to debug our application later. And for now, what I'm gonna do is decode this payload to get the path and handle the specific handler registered before for this path. But before this, we need create a new data struct here, call it input. And then boom, we have this ready to be used here. Type input, yes, exactly this, and then yes, vibe coding. Then once we have this input right here, we could return the handler, passing as a key the input path, and then if the handler is equal to nil, we will return an error. What we need to do is just call this handler with the input payload and the metadata that was received here. As you can see, we have this right here. If everything goes well, we return nil as a value for the error. I think that's it. I think we have our router ready to handle different types of advanced state handlers. And now I'm gonna create the entities of the system. To do it, I will add a new folder here, call it internal, and then inside of the internal I will add another folder, call it domain. Inside of this folder, create our to-do entity that will be part of the domain, and let me create our to-do. Okay, I will change this. I'm gonna implement also a completed as a bool exactly, and I'm gonna change this to uint 64. Okay, so now let me define the repository of this entity. I mean the operations that will be performed with this entity. We could even implement errors for our entity here. I'm gonna implement this error right here, error to do not found, makes sense? Yeah. Let me also invalid to do, right? I'm gonna implement a function to create and return a to-do list, right? It will receive a title, the string, a description, it's also string, and a created at. Created at as a uint64, and return, and we'll return it to the. I will improve this logic, returning an error. Let me explain why. So there's a reality that the user tries to create a to-do list with invalid parameters. What if we create a validate function that is also part of the to-do? Then let me call this. If everything goes well, I will return the to-do and nil of our error. Okay, that's it, I think so. Okay, let me double check this. Okay, I'm gonna add here a find to do by ID. Maybe it makes sense, at least for the update logic. Okay, to start this new implementation, I'm gonna create here this folder, call it infra, and then inside of this folder, call it repository, a file for the implementation. I'm gonna use a in-memory approach, so let me define this as it is. Okay, it will be part of the repository. I'm gonna create a type, call it to do repository, and then in memory it will be a struct. What we will have here is a DB, right? That will be a map from uint to do. The idea here is make each to do indexed with your ID. So let me import this from domain. Okay. Then we need a mutex to prevent from race conditions and segmentation faults, memory problems. Then I'm gonna implement the next ID right here. It will be used to set the ID to start from 1 instead of 0, and then I'm gonna create a function to return this. Okay, makes sense. Let me start the implementation of the repository. I think it will work. Yep, that's exactly what we want. Then define all repositories will be exactly like this. Okay, let me just domain to do, and then it will lock and unlock before to return the specific to do from this ID, and if this doesn't exist, it will return this error. Okay, then the update. Okay, I will change this implementation of the update here because I want to make sure that only updatable fields will be changed. We have all methods from the repository implemented here, and then that's it. So that's it for now, guys. In the next video, we will continue the implementation of this application, creating use cases, handlers, and testing the entire flow. I will see you in the next video.